Hello everyone, thanks for being here. In this presentation, I'll show some early research work that we're doing at the company I work for, Strumenta. Strumenta is a consulting company specialized in language engineering. So we build all sorts of tools to work with formal languages. So parsers, code editors, transpilers, domain-specific languages, and so on. And uh, key concepts in the area of language engineering uh, match quite nicely with concepts in the model-driven engineering camp. Uh, this is, as I said, a research effort, but it stems from real-world requirements that we gathered in working with a specific customer. So it's something with a certain concreteness to it. So in the demo that I'll show you in shortly, we're going to blur a couple of lines that we kind of take for granted most of the time. And one of those lines is the one that gives the title of this talk. So the line between textual and projectional editing. So for those who are not editor experts, um, textual editors are, in the context of editing code, are editors that both store the contents of the editor as plain text and present it as plain text, maybe with some decorations or colors to make it more easily readable and browsable. In contrast, projectional editors are a kind of advanced editors that allow users to directly interact with the underlying model without going through a parser. So while they may still present some or most elements as textual, actually the interaction is directly with the model, and they open up the possibility for using presentations that are not textual in nature, such as tables, images, diagrams, and so on. And we're gonna blur that distinction here. And another distinction that we are gonna blur is one that we usually learn very early in our journey through computing, and that's the distinction between a text editor and a word processor. So a word processor is something that you use for writing documentation or novels or manuals, whatever has to be read by other humans. While a text editor, even if it's an advanced code editor for developers, is primarily used to write text that will be read by machines and other humans, of course, but the machine readability is necessary. So we use a text editor to write configuration file, shell scripts, and even entire software application. And so that's a distinction that is learned early and very well ingrained, and we're gonna blur that too. So getting to the demo that you see here, this is a rich text editor built with a toolkit called Prose Mirror. And Prose Mirror is a library or a set of libraries to build rich text editors for the web. And the key characteristics that distinguish cross mirror from most competitors is that cross mirror, unlike for example Microsoft Word or Google Docs, um, allows the developer of the editor to have freedom with the schema, so with the structure of the document, what we call here document model. So uh, whereas in a traditional word processor you can edit rich documents but with a predetermined and fixed structure, like I don't know, you can have a paragraphs that contain for example images and bulleted lists, but the elements and the relationship between the elements that you can place on the page are fixed. Whereas in prose mirror, that's not the case. It poses very little requirements on the structure of the documents, and uh, we leverage that to build what I'm showing you here. So here we have a what appears to be a traditional, if minimal, rich text editor where you can edit some text and apply markup. So, for example, bold or italics. But then we enhanced this editor a bit, and we added the capability to write also some code, as the text says here. So here we have a rich text block, and starting just below, we have a code block that is a block of text that is hooked into a parser. And here we've chosen a parser for the Kotlin language, which is a general purpose programming language. But you could integrate domain-specific languages, modeling languages, every language that can be parsed from text. So here, for example, I can write some Kotlin code, and we see that the parser is reporting errors on malformed code. So I can write, for example, import something, class, whatever. This is a regular code, but we can see here we see the document model that is underlying what we see in the editor, and we can see that the document model includes both rich text parts with markup, and if we scroll a bit down, we also see these kinds of blocks that are parsed, and inside the content of the block we see a parse tree. So basically a conceptual model of the text that we wrote here. So a model of that text that reflects the structure of the language. So we can see that we have a list of imports, and one of them is a simple identifier named foo, and also we have a class declaration, and it has a name that is a simple identifier, and it's bar, and it has a body, and so on. So here we see a logical structure derived from parsing this code, and that logical structure is intermixed in the same document model that we also use for rich text. But we didn't stop here. We wanted to blur the line further. So now we're blurring the line between a code editor and a word processor, because we can mix and match code and rich text. But we now want to blur the second line between a textual editor and a projectional editor. So instead of writing the class declaration manually, I'll insert a special class node that is a projectional node. It looks like it's text, but actually it's made of parts that we cannot edit, like keywords or punctuation, and parts that we can actually edit, such as the name of the class. And we can see that this is again reflected in the document model. So we have a block of kind class, and we see there we have some keywords and we have fields that the user can edit. And here, for example, we've set the some class text as a value of the name field of the class. And then we can mix and match these elements that we have. So inside the body of the class, we can again write Kotlin code leveraging the parser. So we can see here we get a parse error if we write malformed code. So here we can declare some method, for example. And again, we can mix and match, and we can have, for example, a special projectional method node. So we can gracefully combine rich text with code, and to write code we can either write it as text and run it through a parser, or directly write and interact with the structure of the code. So here we'll have, for example, a method block. We will have a method block with, again, a name and a body. So this is, of course, very early work. To turn this into a product, a lot of work is needed to smooth out the interactions between these elements, make it easy to edit them, and bring the experience of on par with more established solutions. But I think this approach is interesting and quite novel. Now, of course, the document model that you get from such an editor is heavily tied to the presentation, so the structure of the text that you see on the screen, but with some transformation that we can imagine as a model to model transformation. We could, and that could be the next part of our work, we could take this document model and build from it a logical model that drops all presentation related stuff and encodes the same information into a model that is closer to the mental picture that we may have of such a document. So the key takeaway that I want to stress is that a well-designed word processor that is open for extensions like Prose Mirror is a viable base for a model editor or rich code or DSL editor. Thank you.